Hi, so I'm showing here today our whole Infineon offering for wearable applications. So Infineon, we have our product portfolio. We have a huge product portfolio of different functional blocks which go into like every different design element of a wearable device. On this side here I have some demos of or showcase of products where Infineon products actually enable the design of these products. For example, we have our Wi-Fi Bluetooth combo IC, which is for example present in the Galaxy Watch 4, which is present in the Fitbit Versa, which is also designed into this unique product developed together with Ray-Ban and Facebook, the Ray-Ban Stories glasses, and then also our Bluetooth ICs which are going into other wearable devices as well. So we really have a lot of solutions in connectivity with the low power consumption that is required for wearable devices. Here is also an Oura Ring. So we also have our microcontroller portfolio with our PSOC family, which is designed specifically with very low power in mind and specifically for wearable applications. So this is also a very unique product which is bringing in a lot of health monitoring functions and is enabled by our PSOC 63 with Bluetooth integrated Bluetooth product, and it has a battery life of around 6 days. So which is basically coming also because of the low power consumption of our MCU processor. Here we have our offering for an evaluation or design board from Infineon. So this is bringing together all of our products from different product lines, from these different business lines together into one evaluation platform. So it has the PSOC microcontroller on it, it has the Bluetooth Wi-Fi combo IC, it includes the silicon microphone, it has also the integrated CapSense functionality. It also has an extendable shield-to-go interface, so you can also add additional sensors such as the CO2 sensor or, for example, the pressure sensor. And our customers can actually use this to do their prototyping and really build their next-gen wearable device around our portfolio. And here we have a lot of payment stuff. So Infineon is not only doing like active NFC payments, we also have our SPA2 products which enable us to bring payment into any kind of form factor. For example, whether it's a simple ring, whether it's a fashion brand like a bracelet, so you can actually use this to enable payment in any kind of form factor because it's completely passive. You don't need a battery because when you put it against an NFC terminal, it's basically getting the power from there. What you also see here is this Infineon demo of a kind of a card which is combining also biometric authentication together with NFC payments, so prevent misuse. So with this you can actually authenticate with your fingerprint, so that if someone else gets access to your card, for example, when it's stolen or something, it cannot be misused. So really with Infineon, we have a whole product offering. We really enable the whole ecosystem for wearable designs with our offerings such as tools, such as our products, such as our design enablers and everything. So you can really, our customers can really design the next gen wearable with all of Infineon products around it.
What you see here now is a demonstration of our system, which is called hearing car, and it's demonstrating a use case of the microphones, where you use the microphones to detect some ambulance sound from the outside. So which means that you place the microphone modules on the outside of that vehicle. In this system there are 3 microphones in the rear and 3 microphones in the front. They are placed on such a little PCB, and they are directly connected to the A to B transceiver, and then the signals, the audio signals, are then transferred via this A to B bus to the microcontroller. And then what the system in there is then doing, there's a special algorithm running on the system, which is coming from our software partner Cerence, and this algorithm is then checking if there's a siren out there, and if there's a siren detected, then it's also triangulating where of the angle of arrival. And this is what I can now demonstrate. If I'm playing here in a siren sound now, this is a siren sign, then you see that the vehicle is basically sending an alarm off, and it's also indicating where the siren is coming from, and the red LED is pointing towards the direction of these currents. And this basically is how the system works, and if the sirens is sending off, then it's basically getting off again. And the special thing about the thing is that we are using here our automotive qualified MEMS microphones, and these MEMS microphones are the first automotive really qualified microphones according to the AIDEN ECQ 103, which are on the market, and they now finally fill the needs of the OEMs, that they are that basically every component in the vehicle normally has to be automotive qualified. Until now, all the microphones which are used in vehicles, either on the inside or on the outside, mainly on the inside, they only used them in consumer microphones. But the advantage of these automotive qualified microphones is now that they have an extended temperature range from -40 to 105 degrees, and they also have an extended availability of 5 to 7 years, which means that these microphones will be definitely available for a complete vehicle life cycle, or for a complete vehicle production cycle, which are typically 5 to 7 years. Yeah. And that's the thing what our microphones are doing now.
Hi, today what I'm showing is our 60 gigahertz radar technology using what we call antenna in package technology from Infineon Technologies. So today my demo, what I will show you is an in-cabin monitoring application where I'm simulating the seat occupancy detection in a vehicle. So you can see here I'm in the driver's location of the vehicle. If I change seats, it'll show me in the passenger's seat location. If I go to the rear seat of the vehicle, it will show me in the rear seat of the vehicle. And now what I'm going to do is I have a little doll here that will emulate the respiration of a child. And I am now going to jump back into the driver's seat of the vehicle. And the scenario is I'm driving, and my wife gives me a call on the phone. She says, "Hey, we need milk for our child." I pull over, I grab my phone, I'm into the store, I'm looking for the milk. And then the next thing, there's an alert that I get on my phone, and it says, "Hey, your child's in the vehicle," and it will also give what the respiration of that child is that's left in the vehicle. And then my wife also gets the same thing on her phone. She says, "Hey, our child's in the vehicle." So I run back, I get back in the vehicle, and it detects me back in, and this is the safe condition. This is how we want the system to work. And so the next thing I will show is what we call intrusion detection. Okay, now what I'd like to demonstrate is intrusion detection mode using the 60 gigahertz in-cabin radar. So what I'm going to show first is what we call perimeter detection. And as you see, as someone enters the perimeter zone of the vehicle, I will back up so this clears, that we can detect someone physically in the perimeter on the left or right side of the vehicle. So now let's say I'm a bad guy looking in the vehicle, and now I want to take something from the vehicle, and so what happens is the intrusion alert comes up immediately. And again, this is using our 60 gigahertz radar technology to detect intrusion alert. in the vehicle.